2 videos to go, Matrix. We're getting there, we're getting there, we're getting there. Right, and let's share the screen. Visualizer. Right, you should have your textbook open, guys. You should have done your pre-work. If you haven't read through the stuff, page 265 to 274, okay, you're kind of going to be wasting your time with it. So if you haven't done that reading, okay, I want you to stop now, press pause, go read page 265 to 274, okay, and then also I sent you this note, okay, about probability mass functions for binomial and hypergeometric. Go to that as well. Right, press pause, come back when you've done that. For those of you who have done it, okay, you'll see that it's not such a bad section. Basically, it just says a probability can be expressed as a function. And you've done this before, actually, okay, in various different ways. You've looked at binomials, okay, where we did a probability mass function for binomial distributions. You had those in your tests, okay, a couple of times, okay, and we've had a look at for hypergeometric as well. Okay, so just to remind you, okay, when we did a probability mass function, we did for probability mass functions, you can read probabilities off from a table, from a graph, okay, and you can write it as a split function for x an element of whatever the x values are. Okay, two of the most common types, so probability mass functions, and we'll deal with probability density functions later. Probability mass functions, okay, two of the most common types are your binomial probability mass function. Okay, let's just check you can see that. Okay, I sent you this note, by the way, so you got it. So remember, when do you use a binomial? When there are two outcomes, when P is the probability of success, X is the number of successes. Key things is that they're independent, the probability stays fixed. And then you're going to use that formula. So a typical example that I've used often is you've got a netball player, the probability she scores is 0.7. In other words, P is 0.7. Okay, if she has 10 shots, in other words, N is equal to 10, go write down the probability max function. So you should define X as being the number of goals scored, and then the probability that X is equal to X. I always write down naught elsewhere. Just write that down, pick up that mark. Who was it that kept forgetting to do that and lost a couple of marks? I can't remember. Somebody. Normally. Okay, whatever. Right. And okay, so then, okay, you've got to write this as a function of X. So as a function of X, you can have what's your probability of getting X goals from 10 shots. P is 0.7 to the X, 1 minus P is 0.3 to the 10 minus X. So that, okay, is a probability mass function. So you've done them before. You're just expressing probability as a function with one variable. Where you're putting in X values, what are you getting out? You're getting out probability, okay? Hypergeometric, okay, is, remember when we use hypergeometric, first of all, why is it a probability mass function? Because it's discrete data. It's not discrete, it's a probability density function. Okay, but in a hypergeometric, it's when you're taking a sample from a sample. Okay, probability is not fixed. It generally involves combinations. Okay, and you're taking one group from another group. Okay, and there's no ranking within that group. That's why it's combinations. Okay, so the typical example would be you've got 20 fruits in a bowl, 6 are apples. Choose 4 fruits. Okay, what's the probability? Do a probability question would be find a PMF, a probability mass function for the number of apples. Let X be equal to the number of apples chosen. Okay, so just start off and say naught elsewhere. Okay, and your probability function, well, what are you doing? You want to get X apples from how many? 6, which means that you've got to get 4 minus X non-apples from the remaining 14, right? Overall, you're choosing 4 from 20. I always start and write this down first. Okay, what are you doing? You're choosing 4 from 20. 4 fruits from 20. Okay. The specific example, this is our subsample. What do we want to know? The number of apples from 6, and then a kind of its negative space here. 4 minus X, 20 minus 6. Okay. Remember, X minus 4X must add up to 4. 6 plus 14 must add up to 20. That's always your check. So that's two classic probability mass functions. Okay, one is for binomial, independent variables, 2 options. Others when you're taking a sample from a sample, hypergeometric, involving combinations, nothing new there. Okay, right. Then, to go back to your textbook, okay, they went on, Okay, they talked about domain and range. Domains what goes in, range what's come out, nothing new. Don't worry about the normal distribution yet, but the key idea is going to be that with discrete variable, you end up with graphs like this or a table like that, and you can read off the probabilities. Okay, and that's going to be called the probability is called the probability mass. However, with something like a normal distribution, okay, just remember that your probability is an area. Okay, so you're going to end up with finding areas. Okay, and the sum of your areas there must be equal to here. The sum of the areas must be 1 for probability density function. Okay, but here if you add up the y values at the top of the bar graph, those must add up to 1 because your probabilities have to always add up to 1. Another key idea, remember, is that probabilities have to be positive. Okay, probability mass functions are going to be for discrete, probably like binomial, etc. Density is going to be for normal distribution, generally speaking, is the one we're going to use. Right, so PMF's discrete. Okay, then it goes on to show the different forms that they can be represented. You can read the probabilities off from the bars, from the table, histogram form, and the function form for probability mass function is something like that. Okay. Properties of probability mass functions. Okay, remember the key thing is, okay, it has to be discrete. Individual probabilities have to be stuck between 0 and 1. Okay, if they're bigger than 1, it's no longer one individual probability can't be bigger than 1. And they all have to be positive. As soon as you've got one contradiction, one thing that doesn't meet this, none of them meet. And then lastly, the sum of the probabilities must be equal to 1. They work through a whole lot of examples. You should have worked through those. If you haven't, go do that. Okay, right. And I'm going to work through exercise 1. Okay, A and B and 3. Okay, 1A, B, 3, 6A and B, 8A and C. Right, so let's get going. So question 1. Okay, so we're looking here. It says you've got, so give this a go if you haven't tried it. The question says, are the following probability mass functions? And they give you the function. They say the function is the probability of x is equal to x is a 14x squared. So how do I test if it's a probability mass function? Well, you're going to sub in for all the relevant values. So and then we're going to see, first of all, the individual probabilities should be between 0 and 1. If they're not, immediately you stop. Okay, as soon as you find an individual probability that's not between 0 and 1, it's not a probability mass function. You can't have a probability less than 0 or bigger than 1. Okay, so let's just check. If x is equal to 0, then the probability of x is equal to 0 is going to be a 14th sub in x is equal to 0, which is 0. Okay. If x is equal to 1, the probability x is equal to 1 is going to be a 14th times 1, which is 1 over 14. If x is equal to 2, the probability that x is equal to 2 is 1 over 14 times 2, which is 2 over 14. Okay, write this question down correctly. 1 over 14, x squared. Okay, 1 squared is 1, 2 squared, sorry. So it's going to be 4 over 14. Okay, and x is equal to 3. The probability x is equal to 3 is going to be 1 over 14 times 3 squared, which is 9 over 14. So first of all, our individual probabilities, okay, the conditions for every individual x value, probability x is equal to x, okay, is, well, they're all bigger than or equal to 0. They're all less than or equal to 1, okay, so the individual criteria get met, okay. I should mention that they have to be discrete. Is it discrete? Yes, it's discrete. It's not 1, 2, and 3. It's not continuous. Discrete values are going in, discrete values are coming out, okay. But last of all, we have to check, is the sum of the probabilities equal to 1? Well, the sum of the probabilities in this case is 1 over 14 plus 4 over 14 plus 9 over 14, which is 14 over 14, which is 1. So all three criteria, okay, are met. All the probabilities are positive. Okay, they're all less than 1. It's discrete data. Okay, and the sum of the probability is 1. If all three conditions are met, what can I say? Therefore, P of x is equal to x is a probability mass function. Okay, so those are the conditions. Individual probabilities between 0 and 1 has to be discrete data. The sum, all three of those conditions must be met in order for it to be a probability mass function. Okay, you've got to sub in the values. Okay, next question. B. You've got a probability mass function 2 over 3, 5 minus x. X is an element of 3, 4, and 5. Right, and it's 5 minus x. So if I sub in, x is equal to 3. Okay. If x is equal to 3, I get probability of x is equal to 3 is equal to 2 over 3, 5 minus 3, which is going to be 2 over 3 times 2, which is 4 over 3. If x is equal to 4, probability x is equal to 4 is equal to 2 over 3, 4 minus 3. Okay, we'll stop, pause. Okay, straight away, the probability, if I put in x is equal to 3, I get 4 over 3, which is bigger than 1. Okay, so straight away, it's bigger than 1. Okay, so therefore, probability x is equal to 3 is greater than 1. And straight away, I can say now, that's absolute nonsense. This function, whatever it is, can't have anything to do with probability. So p is equal to x is not a probability mass function. If one of them being negative, I could have stopped and said the same thing. If they were all between 0 and 1, the last check I'd have to make is, do they all add up to 1? Some of the individual probabilities. If they don't add up to 1, it's also not a probability mass function. Okay, right. I wanted to get on the side of my page. Check that we've got. Okay, so that was question one done. Okay, 1A and 1B. Okay, right. Next question we're going to do, okay, is question 3. Okay. So, question 3. What do we have? Okay. The question says, okay, you're given a probability mass function, okay, and we're told that in this probability mass function, okay, probability of x is equal to x is 2x plus 3 over k, okay. The question is, and if for x is an element of 1, 2, and 3, so we're given the function, but now there's a difference. In the previous question, they said, oh, is it a probability mass function? Now they tell us, yep, this is a probability mass function. Okay. Based on that information, you've got to go find k. And what's the key idea? The key idea is that the sum of the individual probabilities, okay, must be equal to 1. So first of all, you have to, in other words, okay, in this case, what can I sub in? I can sub in 1, 2, and 3. Those are only x values I can sub in. So if I sub in x is equal to 1, I'm going to get, when x is equal to 1, you're going to get probability of x is equal to 1 being, sub in x is equal to 1, it's 2 times 1 plus 3 over k, which is 5 over k. Okay, so there's your first probability. When x is equal to 2, the probability of x being equal to 2 is going to be 2 times 2, you can skip out steps, plus 3 over k, which is 7 over k. So I've got 5 over k and 7 over k. Okay, and when x is equal to 3, the last one, the probability that x is equal to 3 is 2 times 3 plus 3 over k, which is 9 over k. So those are your three probabilities. 5 over k, 7 over k, 9 over k. They tell you it's a probability mass function. So therefore, 5 over k plus 7 over k plus 9 over k must be equal to 1. In other words, 5 and 7 is 12 plus 9 is 21 over k is equal to 1 times k, and in other words, 21 over k here, 560, 512, 21 over k is equal to 1. So k, is equal to 21. Right. So you end up is k is equal to 21. Double check I haven't made a careless mistake. Yep, that's right. Okay. So the key idea, if you're told that it's a probability mass function, is that the probabilities must add up to 21. Right. The next question says, based on this, go find the probability mass function. Well, if you look at your formula sheet, find the, based on this, find the expected value or the mean of the probability mass function. The expected value is what we expect to come out, okay, in whatever this experiment is. And if you look over here, okay, that formula is given to you over here. E of x is equal to the sum, okay, of the x value times the probability of x happening of each individual one. So that's your key formula here. E of x is equal to sigma x times, so what you've got to do is you've got to times every x value by its own probability and add them up. Okay. So what did our probability mass function look like if k is 21? If we draw a little table, we've got x, and then we're going to have, x, probability x is equal to x. Our x values are 1, 2, and 3. Probability values that go with them, well, when x is equal to 1, we got 5 over k, but k is equal to 21, so it's 5 over 21. The next one was going to be, when x is equal to 2, it was 7 over 21, and when x is equal to 3, it's going to be 9 over 21. Right. So that's your probability mass function expressed in table form. When x is 1, the probability of getting x is equal to 1 is 5 over 21. When x is 2, the probability of getting x is equal to 2 is 7 over 21. And when x is 3, the probability of getting x is equal to 3 is 9 over 21. If you check that, add up to 21 over 21, which is 1. So we look like we're on the right track. Now the question says, go find the expected value of the PMF. In other words, it's sometimes called the expected value, is sometimes called the mean of the probability mass function. So to find the mean, what that formula is saying is that E of x is going to be equal to x times probability. So it'll be 1 times 5 over 21 plus 2 times 7 over 21 plus 3 times 9 over 21. So we'd expect, okay, and if you go work that out, you get 5 over 21 plus 14 over 21, 2 times 7, plus 27 over 21, and we should get an answer of 46 over 21, which is equal to 2,19. So you'd expect whatever this to get an outcome, the most of around about 2,19, which makes sense because it's somewhere between 2 and 3 kind of thing is the most likely outcome. So that would be your expected value, which I'm correct, which is 2,19. Okay, so your expected value formula. Okay, what do we say? How do we express? We say what is the expected value of the function, or we say what is the mean value of the probability mass function. Okey-dokey, that just 3B. Question 6 I really like. You've got a probability mass function, so you're told once again it's a probability mass function. What's the key idea? That the sum, okay, of all the probabilities then must be equal to 1. That's going to be our key idea over here. The sum of your probabilities is equal to 1. Okay, and the function this time is that the probability of x is equal to x is a times 2 over 3 to the x. Okay, and the x values that can go in is any whole number. In other words, 0, 1, 2, 3, an infinite set. Okay. So first of all, it says find the probability that x is less than 0. Okay, less than 1. Okay, they should really have said in terms of a. Okay, in terms of a. Okay, the probability of x is less than or equal to 1 is equal to probability that x is 0. We can sub in 0 because it's a whole number. Okay, if it's just natural numbers, the set would start at 1. X is equal to 0 plus the probability x is equal to 1. Probability that x is equal to 0 is sub in 0 into this formula over here, and you get a times 2 over 3 to the 0 plus a times 2 over 3 to the 1, which is going to be a 1 plus 2 over 3, which is going to be 5a over 3. Okay, so you get an answer for that. Probability, depending on what the value of a is, that if x is less than or equal to 1, you should get an answer of 5a over 3. Right, now here's a more interesting one. The next question says, go find the value of a. Well, to find the value of a, I've got to use, in a probability mass function, whenever you're asked to use a variable, this is what you're normally going to be using. You're going to use the fact that the sum of the probabilities is equal to 1. Right, now they gave us a hint of how this, so what's going to happen? What does the sum of the probabilities look like? Well, it's going to be just like we're doing over here in the previous question. The first probability will be a times 2 over 3 to the 0. The next one will be a times 2 over 3 to the 1. The next one, you sub in x is equal to 2, because we can sub in any whole number here. That will be a times 2 over 3 squared, etc., plus a times 2 over 3 cubed. Okay, that's enough. Plus, plus, this is going on forever. And what do we know about that sum? These things have to add up to what? Okay, well, the sum of your probabilities must be equal to 1. Using that key idea over there. Okay, so if we neaten this up, well, we can take out a, okay, and you get, you don't have to even simplify it, you're going to have 1 plus 2 over 3 to the 1 plus 2 over 3 to the 2 plus 2 over 3 to the 3, etc., going on forever. So what do we have here? What is this thing over here? Well, hopefully that should be screaming at you that you've got a geometric series, and in that geometric series, a is 1, and your ratio is equal to 2 over 3. And remember, if your ratio lies between negative 1 and 1, you can find the sum of the infinite series. And how do we find the sum of the infinite series? Well, we've got a formula that the sum to infinity is equal to a over 1 minus r. Okay, so we're going to be using that. So a, in other words, times, well, if I sub in a over 1 minus r, so these things will all add up to what? They'll add up to a times 1 over 1 minus r, where a is equal to the value of the first term, which is 1, over 1 minus r. Your ratio is 2/3, so it's 1 minus 2/3. So those things times together, so a times, that's the sum, it's the blue bit over here, of 1 minus 2/3, but that sum must add up to 1. Okay, so I end up with a times 1 minus 2/3 is a third. Am I right? 3 over 3 minus 2 over 3 is 1 over 3. 1 divided by 1 over 3 is 3. So that's going to be 3 is equal to 1. Okay, the sum of all of those things is 1, because this sum adds up is going to be equal to 3. So I end up with, therefore, a is equal to a third is your answer. So you're using sum to infinity. Very nice question. I think this came straight. I think the textbook said this came straight from a final exam. Yep, so I end up with a is equal to a third. Okay, get that all down. Okay, nearly there. Let us be. Right, the next one, they give you the table and they say to you it's a probability mass function. Well, you can see it is because they all add up to 2, 5, 9, 14, and they want the equation. So you're going to just say probability of x is equal to x, and straight away I'd say naught elsewhere, and we're going to give some function for x is an element of what can go in there. Okay, it's 0, 1, 2, and 3. Okay. So, well, if we look at the function, the denominator in these things is always fixed. So it's going to be something over 14. At the top, okay, what have you got? You've got a series 2, 3, 4, 5, right? Okay. So how does it relate to x? You can either go use your sequence for natural numbers, but that plus 0 plus 2 gives you 2. Look at the relationship between x and the top number. Add 2, add 2, add 2. So what are you doing to x every single time to get the numerator? You're adding 2. So it's simply going to be x plus 2 over 14. Always check if it's working. Okay, you'd get, if x is 0, you get 2 over 14. If x is 1, you'd get 3 over 14. If x is 2, 4 over 14. If x is 3, 5 over 14. So it's working. So probability of x, the probability mass function is going to be x plus 2 over 14. when x is an element of 0, 1, 2, and 3, and 0 elsewhere, and that is your answer. Right, this one as well, find the equation. Okay, so straight away, find the probability mass function. We're going to have 0 elsewhere. Okay, and you're going to have something for x is an element of, again, it's going to be 0, 1, 2, this is question 3, by the way, and 3. So what's the formula? Okay, well, in the denominator, we always have 15. So it's going to be something over 15. Okay, if you look at the top numbers, 1, 2, 4, 8. Okay, what are we doing to that? It's a geometric series, isn't it? Okay, 2, 4, and 8. Okay, could we use Tn is equal to, so we're timesing by 2. Okay, we're just timesing by 2, aren't we? 1 times 2, 2 times 2, no, 2, 4, and 8. Okay, so it's going to be, if I use AR to the n minus 1, I'm going to end up with Tn is equal to, but starting with 0, okay, A is, so I'm looking at this sequence, right? 1, 2, 4, 8. How can I describe that sequence as a general formula? Well, if I use Tn is equal to AR, I'm just always going to just look at the top. Tn is equal to AR to the n minus 1. Okay, A is equal to 1. R is equal to 2, that's your ratio. Okay, and n minus 1, that's your variable, x minus 1. So if I add 2 to the x minus 1, let's check. If I put in 0, okay, hang on, 2 to the x minus 1, the first value you've got to put in, no, it's just going to be 2 to the x because you're starting with 0. So if you have 2 to the x, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8. So it's an exponential. Okay, so you're going to have 2 to the x over 15 is going to be your answer. Let's check. 2 to the 0 is 1 over 15. 2 to the 1 is 2 over 15. 4 over 15. 8 over 15. Should have got that quicker than I did. Okay, so sometimes the top number is a linear. Sometimes the top number is a quadratic. Okay, and sometimes it's geometric. The denominator is always fixed. Okay, and when you look at the top one, just be careful with the x business. Remember, your first number that you sub in is 0, so you're going to have to compensate for that sometimes. Right, consolidation work, 9 and 10, I really recommend you do because that's a binomial. Okay, but you've done this before. Actually, all of them, okay, you can give it a go. It's C, D, 4, 8B, D, 9, and 10. Try that by yourself. Okay, and that's the end of probability mass functions. I think it's actually a pretty easy section, as is probability density functions, which we're going to do next. And one more lesson to go. Bye.